Amit Paul Singh, you have a question?
I just want to say, sir, I'm present.
Okay, yeah, I got you, Amit Paul.
Okay, thank you.
Okay, the only guys I've marked absent are Daniel Eugenio and Ronak Jensari. Everybody else is here. Okay, and those guys can catch up watching the Zoom recording that I will post after the meeting and as soon as they send me the link. Okay, gentlemen, I'm going to share my screen and I'm going to point out a couple of things here I'm going to need addressed. We are section 3. This is week 1. Sorry about the late release on this. I got busy doing a couple of other things, but here is our lesson for today. I'm going to introduce your first assignment as well. It could be a duplication of what I am going to do today, or if you want to use your own ideas, please feel free to use your ideas, but maintain the requirements for the evaluation here. So I'm going to ask you to create 2 different iParts that have two configurations each. You will have fully constrained sketches. Your parameters will be properly named. You may or may not want to use the sheet metal component. I might use one today in my example. And from my understanding, a couple of guys from the other class told me that they did not cover very much sheet metal during level 2. And the guys that know me, were with me last semester, know that I went through sheet metal fairly thoroughly. We didn't cover a lot of the details of the extra tools beyond creating flanges and controlling your sheet metal rule, but we can retouch on those as we go. You will have a parameter controlled by an equation. You will use at least one suppressed feature. So you'll be creating 2 iParts with 2 configurations each, one assembly that will have 2 configurations as well. So this will become an Iassembly. And overall, you will be handing in 1 3-page drawing. Page 1 will be the assemblies, the Iassembly. So 2 iterations of your Iassembly. And pages 2 and 3 will be the iPart IDWs. Daniel Rojas, I think I marked you present. That's far. Oh, there's Daniel. Okay. Move this thing when I want to. Daniel Rojas. Good morning, Daniel.
Good morning, Professor. My apologies for being so late.
Well, next time you'll get your hand slapped. I'm kidding.
Yeah. Yeah. So you guys can have fun today in the morning. I went to the college. I thought that today we had class on campus.
Seriously?
Yeah.
Oh, okay. Well, how's the weather?
Not bad. -1.
No, I know. It's supposed to be milder today. I'm looking forward to it. All right. So that is briefly the evaluation that I'll be looking for. And we'll take it up next week as to this due date. And I have it scheduled for the end of next week. But if I just briefly go through the course outline for the next couple of weeks, I know I haven't got it fully released. But there's a couple of tweaks I want to make to the grade book and the evaluations that are going to occur this semester. So I've eliminated a quiz. I really don't think that is a proper evaluation for the skills required to create your iParts and your Iassembly. So I want you to actually run through the process of creating those iParts and Iassemblies, and that will be the basis for your assessment for this week. Next week, we do not have an assessment assignment. only this one. This will be the current assignment that you'll be working on. Next week, we're going to look into some software formats. We're going to be looking at the reverse engineering a 2D profile. That's okay. If I look at this, there's 1 hour, an overview of Fusion 360, Onshape, and recap. Well, that's 6 hours. I can't do that all at once. So I'm going to just lightly touch on Fusion 360 and Onshape. We'll have an example of the Recap Pro to utilize 2D photos to create a 3D image or 3D model, a mesh model. Week 3, we'll get into splines and surface modeling. And then in week 4, we will introduce our, I haven't updated this yet, but weeks 3 and 4 will be your plastic injection molded components. Oh, no, that's week 4 and 5. Okay, here we go. 4 and 5 will be designing a plastic injection molded component, comprehending the terminology required just to get around in plastic injection molding. And we'll start our assignment. You'll be creating a plastic injection molded component. And the following week, we will go over the tools required to create the mold design that is a part of the package for Inventor. Week 6 is suggesting interrogation and interference. This could potentially be a fairly slack week. And we could apply sensors and stuff like that. But I want to make sure that you guys are aware of the interrogation tools within Inventor. And creating and using macros in Inventor. It's not the easiest thing. If you guys are into VBA or C programming, you will understand this a little bit better. I have been playing with C programming and the API, the application programming interface within Inventor. And I can show you a couple of things about that. And then we have a week off. That's as far as I'm going to take the summary today. I'm going to go back to week 1 here. And, I know what I need to do. Under course tools and quizzes. So if you guys can see my screen, you can see that we have but one quiz. I have but one quiz to give. And this quiz must be completed. And I want it completed this morning. I want you to take the time and do it right now. This is your exam compliance acknowledgement, and it is a requirement by Conestoga, a mandate that handed down to me for you to agree to the terms of the academic integrity policy of Conestoga. And I want to see this number equal the number of students in my class. If you do not complete this quiz, I have no option but to give you 0 on your professionalism mark. I hope you understand that. Please go in and signify your acknowledgement of Conestoga's integrity policy, and we'll move forward. So I'm just going to wait here until I see a nice big number. That's 13. Oh boy, look at us go. Okay. And refresh again. 17, here we go. Okay, how many guys we got here today? Where'd my Zoom go? We have 33. It looks like the entire class. Okay, no, now 32 because Michelle's in twice. Okay, so I'm going to expect 31 responses to this quiz this morning. There's 21, 10 more. Only 2, 9 more. 24, 7 more. Come on, gentlemen. Let's get this done. We get this class started. It's almost 8:30. $24, 7 more. Where are you guys? Please. 26. Okay, 5 more. 5 more. 27. 4 more. $27. 4 more. Come on. I can only assume that the guys that aren't going to fill this out are smart enough that they can get a 90%, and they don't need that 10% from their professionalism. Things that will be included in your professionalism mark will be your attendance is one small portion. Your communication with me when you have issues with attendance, when you have questions, when you need answers, your class participation is always a good one. And I hate to pick on the language, but when we are communicating in English here, I expect that you will proofread your submission, your file names, your titles, just to make sure that you don't spell assignment wrong, don't spell injection molding wrong. What else? What else? The drafting skills required in this course are going to be a little bit, I'm going to scrutinize you guys pretty intensely as far as the drafting requirement in this class, because I consider drafting to be a critical skill in design. I know that we are designing things, okay? We're not necessarily documenting, but documentation is a big portion of this job. Not everybody is going to be a rocket scientist. And some of us will be left to do the documentation work. And having a grip on the fundamentals of that type of documentation is a big job. So a lot of times when I was working at Sandvik, we were working in Unigraphics, I would just be handed a directory full of models that needed documentation. So understanding the principles of drafting and the requirement afterwards in manufacturing to have a complete print is critical in my mind. And we're at 30. Okay, so there's only one guy left to do that. Well, one guy in this class today. Let's get into Inventor. I have opened up Inventor already. This is my home screen. For you guys that, well, you should all be familiar with Inventor this far anyways. The way I want you to structure your project file for this semester and the way I am structuring my project file is I'm going to create one project file that's going to cover my entire winter 22 semester. So I've created, I do have section 2, 3, and 4 of this class. There's Ronak Jensari. Oh, jeepers, I'm going to put an L on him. Ronak, come on. At least you're here. Please go in and complete the academic integrity quiz. It's the only quiz in your e-Conestoga. Please go in and complete that quiz now.
Hello, sir.
Hello, Ronak.
Yes, sir, I'm present, sir.
I see you there. Please go and complete the academic integrity quiz. Just acknowledge that you're going to have to do this for every class, every time. So just one of the fundamentals, and let's get her out of the road. Okay, so the way I've structured my project file for this semester, I've created Winter 22 project file. Actually, I have a Conestoga Winter 22 directory that has 3 sections in it. And my project file is at the very top of Winter 22. So if you want to divide your assignments into different folders, just to keep it convenient, if I go into section 3, I can see that I have, well, here's my attendance sheet, and there is the week 1 Iparts and Iassemblies. It's currently empty because we haven't created anything yet, but because this project file is above in the directory tree, it is above the section 3 and the Ipart assemblies. It will include everything below it as a part of that project file. So however you are organizing your work, having it in a fashion that includes everything that you need, such as the way I've set it up this year or this semester, it is kind of important once we get to the point where we will be creating our pack and goes. And this works fine. Ronak, yeah?
Sir, I had a doubt.
Yes, Tony.
Yeah. So whenever we are creating a, like, say for the semester, I created a new project. So whenever I need to add a new folder to it, just go here and place it above. Is it like that?
Okay. So if I within section 3, I've created another folder. I'm gonna save all my Iparts and Iassemblies to this folder here. But this folder is below the project file in the tree, so it will be included in this project.
Okay. Yeah.
Okay, all the subdirectories will be included.
Okay.
Okay.
Yeah. Got it.
Okay, good. It's important that we understand the process of pack and go, and we will run through it at the end of this class today. Okay, so if you haven't set up that project file, you can go to your projects here. The following could not be found. Yeah, I know, I deleted that one. Okay. There is the current project file that I'm working with, W22. You can also see it over here in this window. These are a lot of the projects that I've been working on. There's some other semesters and final exams and some plastic injection molding. And this is before I really got nicely organized with my weeks and my W22. So there's W22. And rather than having separate project files for each individual week, I now have a single project file that is going to cover the entire semester. So that W22 project file is located within this W22 directory. I know the name the same, but that's it there. I do have another project file in here as I'm working with some recap data in order to facilitate next week's lesson. Excuse me. Let's see, what else we got going here? Okay, that's all about the project file. Okay, so if you haven't created the project file, it's simply create a new one. Once you click on the project tab, click on new. It will be a single user project. We're not going to get into Vault projects, as that is something that will occur once you get into a management situation where they are using the Vault project. There's a company in Stony Creek just down the road here from me that I've dealt with, and they use the Vault, but they have locations in Spain, Canada, America, South America, and they share a lot of data across the Vault. That's something that you will get into if you need to. So if I click on next, you can type in your project name, find the workspace folder that you wish to utilize for this project file, insert that here. So just by coming to the drop-down menu and go to this PC or wherever it is that you happen to be working, try and not include network drives on this path. Inventor does not like doing pack and goes over network drives. So please be sure to include the path that is somewhere on your own computer or within the drive system of your computer, not a network drive. Okay, so I'm going to cancel this. I don't need to create another one. And I'm just going to work within this directory today, within this project file. And I will just save everything that I create to my section 3 Iparts and Iassemblies directory. All right, I made a little sketch here while I was having coffee this morning as to what it is we're going to present today. And there'll be a couple of parts that we're going to, you don't have to convert them. It's almost like you're adding on a separate identity for a component by creating it as an Ipart. But first of all, you have to create the component. So I'm going to click on the new tab. And I think the first component I'm going to create will be a sheet metal component. And for you guys that remember, the sheet metal IPT and the standard IPT, the difference between those templates, sheet metal has a couple different tools, and we'll get into some of those. The standard IPT is great for your 3D modeling, your extrusions, your cuts, your hole patterns, all that beautiful stuff that we're so blessed to have easy access to in Inventor. Sheet metal is a little bit different. And when I double click on the icon, it's going to open up a new file. And the sheet metal tab will appear here. It's not normally here unless we open up the sheet metal template or we convert a 3D solid model to a sheet metal model. Then we have access to these tools here. It's years ago, it was very important to use the tools for creating sheet metal components because there had to be a flat pattern generated. And when we tried to use the 3D modeling tools in a sheet metal component, the flat pattern would sometimes not work out because some of the features would be left in space. They weren't attached to the surface of the component. Sheet metal makes sure that that happens. It's very fluid in its in the process of working from left to right, as most Inventor templates are. So again, starting this component, let's start with a 2D sketch. I'm going to build myself a bracket today, and it's going to be a support bracket for an axle, and it will have a gusset. So these will be the two components that I'm going to create. And again, if you decide not to use a sheet metal component, you have an idea what it is you want to do with an assembly that might have a variation. This is a great point to make when you are creating Iparts and Iassemblies. If you have a component that could possibly have a variation, something that you might use down the road, or something that might already define an adjustment that you foresee. So creating these components using the Ipart tools is kind of powerful. So first of all, we have to create a component. So I'm going to create a sketch on the XY plane. And let's start with do I want a center rectangle for this? Maybe I'll use a center rectangle for the base, and that way I can, yeah, let's use a center rectangle because I like the center rectangle. When you use a center rectangle, you are automatically, well, not automatically, but it just makes it very easy to grab the origin of this workspace and use that as your origin for your component. If I'm just going to escape the command here for a second. If I create this rectangle out in space here, and I slap 2 dimensions on it, the issue with fully defining this sketch is not the fact that I need 2 more dimensions to fully define the sketch, yet I can see that I know the width and I know the height, but the reason it needs to be, it needs 2 more dimensions is because it's not anchored to the origin. So in this case, I could probably just come in here and put a coincident constraint from that point to this point, and now I'm fully constrained. So utilizing a center rectangle and utilizing the origin of your workspace is a good idea. So I'm just going to hit the escape key. I'm going to select all this and delete it, because I do want to create a center rectangle. And I do want to start at this point here. And you can see my dynamic input boxes. That's 6.02, and it's highlighted. So that's the first dynamic box. It could come up with the height being, or the y-axis. I'm considering horizontal to be the x-axis and vertical to be the y-axis. Anything coming towards me or extruding in thickness is the z-axis. And you can see that down here as well, because this is our gnomon. This is the signifier of our direction in space here. So if I was to type in 2 inches here and 4 inches there, then I've got a length and a height, and I've also got a fully constrained sketch. If I go into my parameters, I can see that I have sketch 1 consuming D2 and D3. So it's named these parameters D2 and D3, and these are the values that I assigned in the dynamic input box. I'm going to Control Z that. I'm going to create another rectangle, and let's create this with some logical parameter names. So I'm going to, oh, that's kind of big. I'm going to type in this value's name. So I'm going to rename the parameter right here. Width equals 2. When it's red, it's not acceptable. When it's black, that means it's healthy. That means the syntax is correct, and the parameter is acceptable. Now, rather than hitting the enter key, I'm going to tab over to the next dynamic input box, and I'm going to put height in here, H-E-I-G-H-T equals, and I'm going to make this 5. And once it turns black, I can hit the enter key. And there we have a fully defined sketch. Let's escape the rectangle command. Oh, why does it say I need 2 dimensions? You son of a gunama. I guess I mispicked my coincident. Okay, let's pick that one and that. Oh, you son of a gun. What have I done? Okay. Okay, let's just move that out a little bit. Let's go make this point down here coincident with that point. Ooh, that's nasty. Okay, I don't understand why I still need 2 dimensions. Anybody? Any answers out there?
So maybe the origin is deleted. We have to project it again, the origin.
What's that?
We have to project it again, the origin.
Turn me up a little bit, sorry. I still can't hear you.
Maybe the origin is deleted. We have to project it again. That's what I'm saying.
Perhaps. Okay.
Can you just try to move the entity?
I can't move.
Or maybe the horizontal or vertical constraint, the line.
Okay, let's just have a look at what constraints are there so we can turn them on. We have a horizontal here and a perpendicular there. This should be fine, because these 2 are parallel and this one is perpendicular to this one, and these 2 are parallel. and have a look at my
Yes,
parameters.
sir.
So let's try the auto dimensioning so we know what was missing.
What's that?
The auto dimension, like the
Yeah, you know what? That auto dimension thing, I never use that because that's going to wind up screwing me up down the road. I know it always does because it adds dimensions that don't add to the function or the functionality of this component.
Sir, can you try to move from the origin, the whole entity?
Try and move.
Yes, from the origin.
Oh, you know what it might be? Wonder if it's if I delete this and delete this. Oh, now I need 3 dimensions. Okay, so that's not it. Let's try and make this the origin because none of this stuff should be fixed as of yet. So I'm gonna try and move this guy again to here. That doesn't want to happen. Okay. Boom. Escape. Try this one more time this way. So I created my width equals 2. Tab over to the other one. Height equals 5. And escape the rectangle command. Oh, it still says I need 2. Oh, okay. All right. Let's try it as a corner rectangle.
Professor,
Yes.
I think like you deleted the entity with the window. You have already deleted that origin. There is an origin, predefined origin. So that's why it's not constraining properly.
I've already created which?
Like you have created a window and deleted the whole entities. So the origin was there. It was also deleted now.
But the origin should, well, let's make the origin visible. Okay, hang on
Center
a second.
point.
Let's finish this sketch and let's make the origin center point visible. Boom. Let's go back into our sketch. I'm just going to double click on the window here and let's create that center rectangle again. And it should snap to that origin. So width equals 2 and height equals 5. Whoops.
so same box here.
Equals 5. There we go. Exit the command. 2 dimensions. Is there more geometry on here that I'm missing?
Sir, it's just going for the reference but not coinciding with the origin. Maybe by the project geometry, you have to project 2 axes and then the origin will appear.
And let's if I over here, it should give me a center point.
It's just going for the reference, not coincidentally properly.
Okay, for some reason I did not snap to that origin point. And when I made that origin of the triangle, which is the green dot right there, and make it coincident to the diamond shape, which is the center point of our origin. Okay, that works out. I don't know why I stumbled there. Okay, so finish that. And now that I have a fully defined sketch, thanks for your patience, I can create a solid. Normally we would go to 3D modeling and do an extrusion. But because this is a sheet metal component, the extrusions in sheet metal components are restricted to a certain thickness. The use of plate in creating sheet metal components or plate or sheet metal, I guess, would have you use a single thickness of material on any single component. So you will never change the thickness of the extrusion that you are creating in a sheet metal component. You can bend it, You can punch holes in it. You can create structural reinforcements, hems. There's a lot that you can create using a sheet metal feature, but you cannot change the thickness of the material. So the thickness of the material is defined by the sheet metal defaults. If I just click on this face icon, which is the second one, so working from left to right, create your sketch, click on face, and it's going to present me with a solid creation panel that is entitled the face. So this is going to be referred to sometimes as the base flange. The very first component of a sheet metal part is sometimes referred to as the base flange, and it doesn't have to be the first one that you create, but the base flange is the one that will be the key, the center point, the starting point, if you will, for the rest of the component. So this face that I'm creating is not allowing me to select a thickness. If I just click OK, my solid is created. My component is, I don't even know what the thickness is. If I go into inspect and measure and just come in onto this corner here, this edge, come here, you. Just want to pick that edge. Zoom in, it's cheap. Okay, so it's telling me that that length is 0.12, and that is because, again, sheet metal tab, our sheet metal defaults are, that's what is dictating this thickness that is created. So if I come into my sheet metal defaults by clicking this icon here, I can see that, yeah, it's set to default. If I hit the drop-down menu, I have two options, default and default millimeters. Well, this is not what I want. This is, so I could come in here, uncheck this and change the thickness here, but I want to be able to follow some rules. Let's create a standard, a new sheet metal standard by clicking on the little pencil here to edit the sheet metal rule. And we can see that, yeah, okay, there's the sheet metal rules that are listed. These are the two that were in that drop-down menu. These are the two that are available to me. Well, that's not enough. I always want more. Somehow I just keep wanting more and more. So I'm going to create a new sheet metal rule, and I'm going to call this sheet metal rule 8647356. That's familiar to some of you guys because that's my student number. Whenever I'm creating sheet metal rules in class, I will apply my student number. When you are creating sheet metal rules, and you will have to if you're creating sheet metal components, because I will dictate that, you must include your student number in the sheet metal rule name. Excuse me. And I also want to put some other information in here. How thick is this material? What is this material? So we can include not that in, well, we can include that in the title. So let's go 1/4 inch. And you can use symbols and such within the style name, but not in parameter names. So this is not a parameter. This is just a style name. And I'm going to put mild steel plate. Or I could probably put in the actual material. We can go steel, comma, and this will be an exact duplication because I remember that steel, comma, space, carbon is a part of our materials library here in Inventor. So this is material is now going to be 1/4 inch steel and carbon. So I can click OK. I can see the name has shown up here. I can see the material hasn't been applied. I can do that right now. Let's go down here to steel, comma, space, carbon. We'll select that one. I want to change the thickness to 0.25 to match the thickness in the title, which is 1/4 inch. And I can also look over here. I can see that 8647356 1/4 inch steel carbon sheet metal rule has been added to the list. So it's now going to be in the drop downs for my sheet metal rules when I select them. But there is a blue rectangle on the default. And if I just zoom my part over so you can see it, Well, you're not going to see the change until I actually save and close this. But if I save and close it now, nothing's going to change. It's still following the default rule. If I open up the editor again, and I come in here and I double click on this one so that that blue rectangle is now beside the sheet metal rule that I want. You can see that the part has changed. It's now 1/4 inch. It's following the rules of this sheet metal default. The only other thing I want to change is the bend radius. So there are 3 tabs in creation of a sheet metal rule, and you have different options depending upon what it is that you're going to be creating. I'm only going to stick to a couple of simple functions of the defaults. The K factor is something we're going to leave alone. I might touch on it briefly in a bit, but I want to change. Well, I don't need to change my relief shape. I'm not going to do anything that complicated today. I just want to make sure that when I'm assigning a bend radius, I want it to be at least twice the thickness of the part. So thickness is a parameter within our, I'm going to cancel this. Thickness is a parameter if we look at our parameters here. And this is another difference between our standard IPT and the sheet metal IPT is that these parameters, they come built into the template. So there's the 1/4 inch size. That's the one I've changed already. If I click done here, come back and, oops, I'm going to change my sheet metal default from the 1/4 inch that we just created back to the default that is applied. And okay, the material changes. And when I come to my parameters, you can see that that thickness has changed as well. Now it's 0.12, and I wanted my part to be 1/4 inch. So the way that you control that is by changing which sheet metal default you need. So select the one that actually has the thickness of material that you want, and it also changes color because it's signed a material here as well. Let's see what else did I got to get. I think that's about it for the sheet metal rule for now. I'm going to come back and I am going to create another sheet metal default because I'm going to make an I part out of this eventually. And one of the configurations I will use will change the thickness of this component. Let's move forward here. So we've created the sketch. We've created the face, which is the solid component of the this sheet metal part. Now I'm going to add a flange. And it's asking me for an edge. So I just want to bend this way. And when I look at the side of it here, I can see that the flange is within the 5-inch height that I've created. So this distance of our original sketch was 5 inches. Now the flange is within the limits of that, or within the envelope of the existing geometry. I can change that by putting it totally on the outside of the geometry. So that change looks like this. So from red right view and zoom it straight in. Let's just go out a little bit. And I want that to be up a little bit more. Okay, so this is the bend position inside the reference plane, they call it. So within the envelope of the existing geometry. So this line here is parallel with this line here when I made it 90. This next bend position option is from adjacent face. So we selected this edge here, and the adjacent face is this one at the bottom. So when I click on this bend position, it moves the flange to be outside or at the end of the piece. And that kind of makes a little bit more sense as far as seeing the geometry. This one here will move this edge, the inside edge, to be parallel with the reference geometry or the existing geometry from that sketch. When I change it, this line here is in line with the reference plane or the geometry, the existing geometry. This last guy on the end, tangent to adjacent face, this is something, it kind of looks just like the very first one. They don't seem to make a difference, but they will make a difference if this value is more than 90 degrees. So if I make this 100 degrees, let's make it 110 just to be a little more. I always hated bending 110 degree angles, and that's 20 degrees over 90. If I put this bend position on the end here now, you can see that this tangency is in line with this line, with this edge that we selected for the bend. And this way, it's this face or this edge here, arc is tangent to the bottom. So it does make a difference if you wanted to include a hemmed component that needed to be a specific width, and I made this 180 degrees. We wouldn't necessarily hem a 1/4 inch plate. Hem is just a fold. It's not going to allow me to do that. Okay, there's that one, there's that one, and there's that one. Yeah, this isn't going to work. Okay, so let's make this 120. This tangency that's occurring because we use this one here, that means this tangency is relative to the reference plane, so the outside of the geometry that we created for our sketch. The other option here would have this edge here in line with the edge that we selected. So you can play with those options. Those are kind of cool when you need to fit something together. I am going to maintain my 5-inch height in this case. So for me to maintain my 5-inch height, I need that flange within the reference plane. So that is this first option that we have. I'm going to change this value to 4 to 3. I like 3. Okay, and I'm going to call this leg. Leg, and again, a dynamic input box, whether it is a dimension on a sketch or a one of the input boxes in your panels here. I'm just going to put leg equals 3. So I can create my parameter names as I go along. And
so is it okay that we change the names or we can keep other names, or if we don't put the names, is it okay?
Well, if you don't put the names, you won't be able to manipulate the parameters logically. When I open up my parameters now,
it will just show 3 inches of some dimension, right?
3 inches.
I mean, like for example, you put in if you have put in 3 inches for so for the leg. So if I am not naming it, it'll be like D13.3.
Well, if I put the leg value into the name, is that what you're suggesting? I wouldn't do that because I'm going to be changing this, or I might tie it to a formula, or it's going to be, I'll show you how to tie this into a spreadsheet, and it's something I wanted to try for a little bit, but I can change the value here and the leg value will change.
Okay, that's nice. Yeah.
But I'm just going to leave it at 3 for now.
Okay.
And click done. You'll notice that I'm just going to go and inspect this. If I look at the thickness of our material is 0.25 as per our sheet metal default that we created. And this radius here should be equal to 0.5. Where is it? Diameter 0.5, radius. Oh, the radius is still 0.25. Okay, so just a little bit of knowledge from a guy who's been on the shop floor long enough to understand within sheet metal environment, we would rarely, very rarely bend a 1/4 inch plate with a 1/4 inch radius. We tried to standardize in industry to avoid cracks. What's happening here is when I strike this face here on the inside where the die is hitting, it's going to compress. On the outside, it's going to stretch. It's going to be under tension. And you will always, depending upon the material, you may wind up with cracks, or it might break all the way across. And I have broken my share of steel in my day. So we try to use a radius that's at least twice the thickness of the material. So for me to go and change that, that's within my sheet metal defaults. And I come back in here, edit my sheet metal rule that I am using. And under the bend, there's the bend radius. I'm just going to go thickness. I'm going to insert a ×2. So let me still see it's 1/4 inch. If I save and close this now, you can see that my radius has changed. So this is going to be a lot easier on the equipment, a lot easier on the top die and bottom die and the brake press, because when this will sit like this for the most part when it comes out of the brake press, and your die will come straight down the center. There will be a bottom die that will be a V shape, and those are normally cut over 90 degrees so that you can bend a little bit over 90 on a standard V block, but you want to try and hit 90 when they ask for it. So this component is now bent. I can create a flat pattern from this component. And when I create the flat pattern, it opens it up. It also drops the feature over into my model browser here. That is the flat pattern that I will use when I create my drawing. This specific flat pattern has a dark center line, which is the bend line. When an operator is laying this out to bend it on the brake press, he will take the dimension that you put on your print to this bend line and lay it out so that the center of the die is going to strike that line. That die will always be centered over the bottom die as well. So once that's laid out and you can strike it, it's going to bend. And these little light lines here on the right and left-hand side of that are the tangency lines. So this is where the bend starts and this is where the bend ends. If I go back to my folded part, you can assume that these lines here are those little dotted lines. They're further apart on the bottom than they are on the top, again, because we have compression on the top and tension on the bottom. So this is my first component. I'm going to save it now. I should have saved it a while ago. And I'm going to save as, and let's go into my week 22, section 3, Iparts and Iassemblies. And I'm going to call this flange. Let's just call it flange. Let's call it bracket. Sure, bracket. And 8, 6, 4, 7, 3, 5, 6. Again, I cannot state it enough how much I need you to put your student numbers in every file that you create. The sooner the better in the process of creation. Put that student number into, let's call this an I bracket, just because it is an I part. So we'll call it an I bracket. And I'm going to save it. All right, I have a component. Yippee-yay. So I can go in, I can modify my parameters here to change. I can't change the thickness or any of the sheet metal defaults or the sheet metal parameters. I can't change those from this window. If I want to manipulate my sheet metal rules and the defaults that are available to me, I have to go to my sheet metal default tab up here and change it through there. The model parameters, however, I can change those if I want. I can change my thickness. I can make this 5 inches. And these are the dimensions from my sketch. Hit the enter key and yeah, okay, it's going to react. It's going to do exactly what I want it to. This leg, make this 1. Can I do that? Yeah, I can still do that. But you want to be careful with how short you make your flanges, because you do need a certain amount of material there to actually create that sheet metal flange. Okay, so I can control this component using the parameters that I have available to me here. but I like this one. I need this component, but I want one similar to it. But I don't want to keep changing my parameters back and forth. So let's make this a smart component. Let's make it an intelligent bracket, an I bracket. The I in Iparts and Iassemblies stands for intelligent. So if I go to my Manage tab, I can see that I have Create Ipart located right here. And when I create an Ipart, it opens up this panel. And if I explain this panel correctly, you can see the parameters that we've renamed here. And I'm going to cancel this for 1 second. I'm just going to quickly, I'm going to create a new component. I'll just make it a standard part. And I'm going to create a sketch and boom. And I'm not even going to concern myself with fully constraining this. Finish the sketch. And because I haven't put any dimensions on, it's not fully defined. Okay, so let's go in and edit that sketch. Sorry, edit the sketch. I need a couple of parameters here. Dimensions. Because if I open this up now, I have no parameters. There's just nothing in there because I haven't defined anything. The parameters hold your definition. Those are the numbers. 777, lucky 7. I think I'm going to buy a lottery ticket today. And okay, so these dimensions don't mean anything. I am fully constrained. If I go to my parameters here, I can see that I have 2 parameters that aren't renamed, and the values are I'm not concerned about the values of those. I just want to show you that when they're not renamed, and I go to my manage. Whoops. Let's finish that sketch. Finish. And I go and I make an Ipart. Okay, so there's in your 3D model, there's also an Ipart Iassembly tab there, as well as rebuild, as well as under the Manage tab. So I'm going to create an Ipart now, and I have nothing in here because I did not rename my parameters. They're not showing up here. I don't have anything to work with. So I need to actually name my parameters. Oh, wait, maybe I should save this first. Let's just save it. And then have a look at Create Ipart. Yeah, we still have no parameters. Not even properties. These we'll get into, but the parameters are the ones that we create. So it will not list its own in most cases right off the get-go. So I'm going to quit that part, and I'm going to come back to this one. When I create this Ipart, these are the parameters that we renamed: height, width, and if I open this one up, I'm going to find leg. So the parameters that we renamed have already been transferred over. If it didn't show up here like this, then you can highlight it in this left panel and move it over to the right. When you move it over to the right, it adds it to this specific table that we have here. Now, the sheet metal pattern or the sheet metal default that we're using, this is the flat pattern orientation, is default. There is no sheet metal rule in here for us to concern ourselves with. But those 2 are going to be located under sheet metal. So there's two columns here relative to your sheet metal part. Under the sheet metal tab, you'll see that flat pattern orientation and flat pattern bend order have been moved across. So if I don't want those columns in my table here, I can move them out. But I think what I'd like to have is another sheet metal rule here. So clicking on the sheet metal rule, this is the one that we're using. I can move it over here. And when I move it over to this side, I can see that it shows up here as a column. And when I click on it, there's a drop-down menu. And this is the list of sheet metal defaults that are available to us. So I pick OK. I'm just going to come back to my sheet metal. I'm going to create a new default. I'm just going to edit the one that we already have because we've already modified the bend radius here to be the thickness times 2. That's a good standard to work with. I'm going to create a new, and it's going to make it as a copy of this existing one. So I'm just going to get rid of copy of. I'm going to change this to boom, boom, boom. Let's make this 1/2. 1/2 inch steel carbon. Okay. And then let's change the thickness in our default here to 0.5. So now when this thickness is 0.5, our bend radius thickness times 2 is going to be 1. So I'm going to save and close that. And let's have one more look. Make sure it showed up here. We can see over here that yes, it has shown up, but it's not the active one. If I come here now and I change that to 1/2 inch, you're going to see the material thickness change. You're going to see the radius change. Let's leave it there for now. That's kind of, that 1/2 inch was kind of big, wasn't it? Well, we're going to see. We're going to see. Okay, let's go 1/4 inch steel. And okay, so take it back to the 1/4 inch bracket. What else do I want as far as details on this bracket? I told you that this was going to be an axle rest. An axle rest bracket. So I have an axle that's going to sit on top of this, and I need a cutout here for that axle to sit in. So I'm going to start a 2D sketch on this face. And again, we're still in a sheet metal component. A lot of the functions, a lot of what we're doing is the same as a regular IPT. I'm going to create a circle. I'm just going to put it out in space here. And I could have filled out my dynamic input box, but I know that I have to dimension this to get it where I want it to be. So I'm going to create a dimension. Let's dimension this guy here first. I'm going to make this diameter. Oh, let's make this 1 inch on the 1/4 inch plate. And let's, I need 2 dimensions. So I need to locate the center point on this. I want to do it just right on the very end and in the center. So let's try with a coincident constraint. I'm going to pick the center of the circle. I'm going to find the midpoint of this line. And now it's fully constrained. So if I change the length of this flange, this diameter is going to be attached to the end of that flange. So that sketch is fully defined. It's good. I can see there's a pin in the corner here, and this is what I look for when I'm creating your assignments. I'm going to finish the sketch, and rather than create an extrude subtract, in sheet metal, we use cut. And it's picked up the closed geometry. It's created the preview of what it is that I'm going to cut. And it's the distance that it's going to use is the thickness. So if I change the thickness of this bracket, it's going to be fine. So I'm just going to pick OK. And now we've created a little bit of a spot where our axle can rest. This component is not going to be strong enough without a gusset on the inside here. So that's going to be our next little guy that we're going to create. I'm just going to save this as it is. And let's go back to our Ipart here for a minute. Now we've got the parameters that we want are here. That we can change, that we want to change. So the width, height, and length. If I go to the sheet metal tab, you can see that the sheet metal rule is also included here. There is a suppression tab as well. This suppression tab will allow you to include or not include specific properties of your creation. So I'm going to go in. I'm just going to put one quick hole here. Let's go back to sheet metal. I'm going to start a sketch on this face, and let's put a hole right here. I could have done it with where's my sheet metal? Hang on a second. That's, okay, didn't keep that sketch. We could put a hole in using this option as well. Now, this whole option is exactly the same as the one in your 3D modeling, but when you're accessing it here, it implies that it's sheet metal. So I'm going to select the position of my holes. Uh-oh. That line has to be blue. Let me start the command over again. I want to create a hole. And bum, 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 bum. Bum, 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 bum. Okay, why is it not allowing me to create a hole?
Sir, you can click it first and then edit sketch so you can set the position.
Yeah, we could do it that way, but I just want to know why. Oh, it's probably, okay, this is it. So there's an icon here that allow center point creation is off. Whoa. So I turn that back on and center point creation is allowed now. So when you're creating holes, it's the same as creating the hole in your 3D modeling. So I'm just going to pick this face here and I'm going to create a hole. And how big is that hole? Well, okay. So under this tab here, I'm going to put in hole. It has to be an underscore. You cannot use a dash here because a dash signifies a mathematical operation, subtraction. Hole diameter equals 0.5. So I'm relabeling my parameters as I go. I need now to assign some dimensions. So let's put a dimension from this edge. And this dimension, I want it to be width. Whoops, it's all caps. Width divided by 2. So it's always going to be in the center. And let's add a dimension from here. And we're going to make this one height. And we can make this. Oh, wait. We're going to call this, what am I going to call this? I'm going to call this, or we'll just make this equal to height. Now I haven't labeled the actual location parameter name, but I can hit the enter key now. And that hole is going to be there. If I change the length of this this flange here, get back to my parameters and find my height and make this 9, then you're going to see that that hole is going to stay in the center. This one's still attached to there. It's all just gorgeous. I'm going to change this back to 5. Okay, so I have a bracket with an extra hole in it because I wanted to show you in our eye parts. Let's go to the Manage tab and create the eye part. Now, that hole diameter is not added here. We could, let's move this over a little bit. We could add that hole diameter because it's now a feature that has parameters in it. And if we open it up, that hole, that's defining the dimension. Oh, okay. And this is defining the diameter. So we can include the diameter of that hole here if we wanted. And we could also include those components within our suppression. So the hole shows up here. And if I move it over to this side, it shows up in a column in our eye part author table down here. And for me to utilize this as a part of a smart part of our eye part. Yeah, okay, that's a lot of art. If we want to use this, then we have to type in the word suppress. Well, this is the way we used to have to do it. But for this iteration, I'm going to leave it the same. I want to make a different bracket. Now, using the same Ipart author, over here, we're going to right mouse click, we're going to insert a row. And however many parts I want, I can insert a row. It's always going to copy the last row or the row that you highlight to create the next row. So for this row, I'm going to change the width of my bracket. Let's change this width to 3. Let's change the height to, say, 6. And let's change this leg. I want to make this leg a little bit longer. Let's make him 4. And I'm going to change my sheet metal rule in the second one as well to the 1/2 inch. And I'm going to come into here. Oh, I could type in the word suppress right here, and it would suppress it in the second instance. So they've already been renumbered 01 and 02. And I've changed the dimensions here. If you see over here, I do have a table that already exists because I opened this up already. But if I click OK now, that table is going to be populated with these 2 items. So there is the first Ipart item, the one we created. And then we used the parameters that we've labeled to create a table to create the second iteration, the second configuration of this component. When I double click on it in the model browser, you can see that it comes up. I still have my hole in here. And oh, I do want to change this diameter because this looks like it's going to be holding a much heavier component. So let's go back to that table for a minute. So you can come back to the table by clicking on the Ipart, create Ipart, or you can right mouse click here and edit table. So that hole that I want to suppress, it's only in this really thick iteration that I want to suppress this hole. Now, what used to happen if you came into your Iparts and you're switching back and forth between the 2, and one is 1/4 inch and one is 1/2 inch. The 1/2 inch one, I want to get rid of the hole. And what used to happen is that this feature tree that we see here was tied to both, and you couldn't edit the feature tree without affecting both parts. If I come down here and I click suppress here now, the hole disappears from our thick bracket. So this is the 1/2 inch bracket, the number 2. If I go back to number 1, it's saying the values in the active row of the table do not match the document's current values. Do you wish to update the table before continuing? So what it's going to do is it's going to change hole 1 from compute to suppress. So it's going to do that for me. And then it's going to switch to the first iteration, which still has the hole in it, and the hole is not suppressed. If I open up my table again, then I can see that it has the word suppress written in here. You can also come in here and you can highlight this and say suppress and OK, and that hole will disappear. And you can see over here that it is suppressed. It's still here, but it just has it's grayed out, has a strike through on the text. So you can do it either way, unsuppress, suppress from the model browser within particular Iparts. Number 2 is still not going to have a hole in it, but that's okay. I want to go back to number 2. So I have to edit my table here because I wanted to include where is that? That is in, is that this hole? No, that's in the cut. Okay, so we created a cut here. That was, and we didn't actually rename the parameters. Okay, so let's go back in. D19 is going to be the diameter of that sketch that we made to do this. So I guess the easiest way would be to edit the sketch. That is not the right sketch. Oh, you know what? I don't need this sketch. I made this one by accident. but it's fully defined. The sketch I want is the cut for this top piece here. Let's go in and edit this sketch. Let's go in and look at the parameters that we have. There's only one location parameter, which is the center to there. But I really do want to be able to control this component here, the diameter. So I'm going to call this axle. Let's do it. Axle and underscore DIA equals 1. So I'm going to rename that parameter. That's not how you spell axle, Tim. That's how you spell the name axle, but that's how you spell the word axle. Okay, axle underscore DIA equals 1. It's going to rename D19 to axle diameter. And if you want to see the parameter names with your dimensions, you can come down here to the tolerance tab here and right mouse, or not right mouse, but you can left mouse click on a drop down menu and change it to expression. So now I can see that that axle diameter equals 1 inch. That diameter is the one that I want to use in my cable. So I'm going to finish the sketch. If I go to my parameters, I can see that that axle diameter has been changed. It's right here. That's the new name. I could have renamed it from here, but it's just as easy for me to go into the sketch where I can see what it's actually controlling. And that axle diameter, I want to edit in my table here. So I want to add that axle diameter, which is going to be under this cut. There's the axle diameter. And I'm going to move this over to this side. Now I have a column here that is going to control my axle diameter. So I'm going to make this 2. I've changed the width already, so we'll still have lots of room on either side. So this is the 1/2 inch bracket. This is the number 2, and this is the number 1. And it looks like the heights are the same on these. Did I not change the height? Edit table. Boom. 2, 1, 5, 6. Yeah, it's not changed that much. Okay, let's make the 7 just to make it a little more apparent. Whoops. 7. Okay. So this Ipart now has 2 specific iterations. If I go into my file manager and I look within section 3 and my Iparts and assemblies, all I have here is that I bracket. I don't need this one. Bye-bye. Just the I bracket that we created. So this single component here is now 2. And I don't believe there is a limit to how many Iparts you can create from a single component, given the requirement. That's okay. Over here, before we actually do anything with our Ipart, especially in the drawing mode, we need to be able to generate these components. And they will exist in the same directory, but you have to right mouse click on either one, actually probably both of them. So generate files, and it's going to, multiple files have been updated. This is just our save notice. And when I go back to my directory here, I can see that a folder of the same name has been created. And within that folder, I have the second iteration. So let's go up to the right here and generate files. That was on the first iteration. I go back to my file manager. Now I have I brackets 01 and 02. So these are referencing solid models. You can send them out. They are not Iparts. They are components created by Iparts. When I go to make an assembly, I'm going to use this actual Ipart to create my assembly, because I want to have the flexibility in my assembly to be able to change this component. Oh, that coffee's cold. Okay, I'm going to make one more quick component here. I'm going to switch this back to the 1/4 inch. And I want to put a gusset on this just to make sure that it's secure and also allow us an opportunity to create an eye assembly. So I'm going to go in, I'm going to go File and New. And it's going to be standard IPT. I don't need much more than that because it's going to be a triangular gusset. So let's create a sketch. And we're going to draw a straight line. And I'm going to start at the origin. I'm going to come straight up. How far do I want that? Let's make this 3. Okay, so I can come in here and I can just, right now, I can type in the word HEIGHT. And this is the same as the one we used in the same name, but it's a different component. So we can get away with that. So height equals 3, enter. And I'm still attached. Zoom out. Ugh. And let's just go over perpendicular, and I'm going to make this one flat. I'm just going to call this flat and equals 0.5. I like to include flats on my gussets because it gives a welder something to weld around. It also eliminates that pointy edge, that pointy corner that could be used as a weapon if that was the case. I'm going to draw this line down here. I really don't know what this angle is going to be, but I'm just going to drop this point here. And this line here, I'll make him, I want it to be at 0. We should be able to see that show up if I just swing through. And now it's parallel to this line over here. And let's touch it on the bottom and let's close the geometry. I'm still not fully defined. So I'm going to end my line command. And it's telling me that I need 2 dimensions. So let's put this dimension here. And I'm just going to make it equal to this one. And I need 1 more dimension here. And that's 2.5 sounds good. 5, enter. I'm going to hit the E key. I'm going to create my extrusion. I want this to be equal to THK. THK, my standard acronym for thickness. THK equals 0.25. Okay, so the only problem I'm having with this gusset is the fact that it has no radius on it. So I'm going to come in here, I'm going to put a fillet on here. I'm going to make this 0.5 so it matches our 1/4 inch gusset. And I'm going to change the name of that before I do this. I can leave the 0.5, but we call this fillet. Sure, why not? Fillet equals 0.5. So now I've got I got parameterized gusset here. If I look at my parameters, it's not a sheet metal component, so I don't have all of those default parameters that are located in the sheet metal template. But I do have my height, I have my flat, I have my fillet, and I have my thickness. Where's my width? That's this one here. Oh, let's go in and just change this one to width. So you can change the names of them here as well. You don't have to actually do it in the dynamic input boxes, but if you do it as you go, it kind of lends a little bit of logic to what it is you're doing. And it forces you to think logically, to be able to put the proper names in the proper spots. So done. Now we have a gusset. Oh, I got to save this. File. Save as. And let's go with I gusset. It's not a pirate thing. I've seen a new pirate movie out there. It's rated I. No, it's rated R. I guess it, and of course, my student number, 8647356. If you happen to hear a couple of dad jokes come out of my mouth, it's only because I am good at it. I'm really good at it. What else we got to do here? I want to create an Ipart out of this as well. Let's create the assembly. File, new, standard IAM. We could go into the development and all that stuff. We'll get into that a little bit later. But I just want to create an assembly using this component. And I just figured out today. I mean, I don't know how many versions of this Inventor. I've missed the fact that I could come into here, and this is my assembly. And rather than clicking on place, I can come into the directory where my components are. I can grab the bracket and just pull it in. Now it wants to add the bracket here. There's the bracket. Which iteration do we want? So when this panel comes up, when you are bringing iParts into an assembly, you're going to get this panel, which is not standard for non-iParts, and it'll allow you to see the actual definition of the component. So it's computing the whole, that's the sheet metal rule, there's the leg, and we can change the values here. We can come up here and you got to click on the value to get rid of it. We can also make it so that there are values that can be selected and cannot be selected, but in drop-down menus. So if I click on the I bracket here and I look at all values, I have access to the second iteration of this assembly as well. But that's not what I'm going to do right now. I'm going to leave it as 1, and I'm going to pick OK. Oh, I'm not going to pick OK. I'm going to right mouse click over here and place grounded at origin. The first component of every assembly this semester. As a rule, the first component of every assembly will be grounded. That will allow you, I'm just going to pick cancel now because we've already got one. If I right mouse click on this guy and I turn off the grounded component, when this is assembled, I'll be able to grab this and drag it around. That's not what I want. I want my components to be relative to the origin where I dropped it. So place grounded at origin. When we first drop that component, we'll put that component at the origin. Let's add a gusset. So I'm just going to, oh, I got to save this first. File, save as, and where are we? We're in the right directory. Oh, it's just that we don't have any other assembly, so those components aren't showing up. So I'm going to call this Iassembly or I bracket assembly. That makes more sense. I bracket assembly, and you can include spaces in these file names, but you should also include 8647356. Include that student number. Include that student number. That's an academic integrity check that I like to verify. If you do it consistently, I will make sure you are rewarded with your proper professionalism marks. Okay, so I'm going to save that assembly. And I'm going to now add the gusset. So let's come back to our file manager. Let's grab the gusset and bring it in. Oh, I haven't made this an Ipart yet, have I? Ooh, okay. Let's go here and let's go back to the gusset here. This is the gusset. Let's create this, change this into an Ipart. So again, Ipart assembly functions are here or under the Manage tab. So manage and create Ipart. And okay, here's the options that are available to me. There's the part number, there's the height, there's the flat, there's the width, and there's the thickness, and the fillet. I think that's all that I need to change. I'm really not certain about the size of that. I know that the size of the fillet on the second one is going to be different because the plate thickness changed and we changed it to 1/2 inch and the bend radius is twice that. So I need this to be 1 in the second iteration. I think I'll change the thickness of this gusset. And this is not a sheet metal component, so I can just change it to whatever I want. 375, which is 3/8 plate. Because this bracket, the one it's going on, the second iteration assembly will be a 1/2 inch bracket. Let's go into the height here. Let's, I know I made that bigger, so let's make this 5. The flat will leave the same. That's kind of a standard. I really don't need that within this chart. So let's get rid of it. So let's go 5 and the width. Let's make this 4. We'll see how that's going to work out once we create our assembly. So, okay. Now we have our Ipart. We have a table up here. We have both iterations of this gusset within this single Ipart. Right mouse click, generate files. Okay, save everything. And I'm going to right mouse click on this one and generate that file too. Now I want to go back to my file manager. I can see that I have an iGusset directory and the 2 iterations or the 2 configurations of that component are in there. Okay, when I go back to my assembly here, I can see that iGusset now has a table because I created it as an Ipart. You can't change it from here. You can't convert the component and flip it from one to the other yet. I got a lightning bolt. Always refresh your lightning bolts. This is iteration number 2. This is iteration number, oh, so it looks like it's brought in number 2. So this, let me just inspect. Never be afraid to inspect. That's part of your job. Go in and make sure you interrogate. Okay, so this is the thicker component. Oh no, I've lost my model browser. So you can come up to view. Where is it? View. And where did that go? User interface and model browser. Where did it go? Model browser, boom. Okay, so if you happen to accidentally kill your model browser, like I just did, go to your view tab, user interface, turn your model browser back on. All right, so I wanted this one to be the other one. I could delete it from the assembly and I could re-add it as the component I want it to be, or I could just substitute it. It's not going to change this way. So what you have to do is you have to right mouse click here, come down to component and replace. So I want to replace that gusset, the iGusset, with section 3, Ipart assemblies, and I want to replace it with the iGusset. I know it seems like it's redundant, but once you replace it, turn on the replace for the iGusset. Where'd it go?
You stop the screen share.
Oh, okay. I don't know why this happens. Let me, I'm going to start this over. Where's my screen? I've seen that happen.
Yeah, you're back on.
Okay. So when you want to replace a component within an assembly, you can right mouse click on the component. Boom. I'm not stuck in anything. Right mouse click on the component, go to component and select replace. I'm going to replace it with the same component, but it's going to give me the options again to change which one it is I want. So I want the first iteration, which is the 1/4 inch. It has the 1/2 inch fillet because it's going to match up with this bracket. And now let's change size. If I come into my inspect and measure, now we have the right gusset in there. And I'm going to X out the right one this time. And let's create a mating constraint. All right, so I am going to assemble this. I'm going to constrain this face. Come here, you. Just the face. There you go. To the bottom. And then I want to constrain. Well, I have to apply that first. Then I'm going to grab this face and constrain it to this face. And apply that. And now I want to center this gusset, despite the fact that I have a hole there. I'm going to center this gusset on the component. And the easiest way for me to do that would be to make sure that I have my work planes in place. So if I open up the origin for the first component or for the workspace, I can see that I have one dead down the center. Now, the reason that plane is dead center is because this is the origin for the assembly. If I go to the bracket and open up the folded model, I have another origin here that will also show me one down the dead center, because I created that first face of that component with a rectangle, a center rectangle that had its origin at the origin of the workspace, at the center point. So this makes it very simple for me to find the center of that gusset or the center of the bracket. But now I just have to make sure that my gusset has a similar origin. And if I come through here, I see I have X, Y, Y's. Oh, okay, see that plane's not in the center? That plane is actually on one face. Let's go back to the gusset here for a second. Let's find that extrusion. Double click on it. It will be we'll be editing the feature in this case. And rather than having it extrude in one direction off of the face, let's make it as symmetric. That's going to move the plane, the work plane, to the dead center. And now I can click OK. I'm going to save it. I'm going to move back upstream to my, I need to update. See lightning bolts? Whenever you see lightning bolts, always update. Okay, and now I'm going to go in and I'm going to look. So there is the origins for my bracket. And down here is the origin for my gusset. So I'm going to constrain, and I'm going to find the plane for that gusset, which is now down the center. I'm going to constrain that plane to this one. And it's not going to give me a preview because it's fighting with itself. If I click apply, I'm going to get an error message. I will go back. I will edit the relationship. I will flip the relationship around by changing it from a mate to a flush. And that's the only alternate solution in this case. And it's going to give me, once you see the preview, you know you're golden. Apply, and I'm done. Okay, so there's something about this gusset I don't like. It's not high enough. Let's raise it up another inch here just to, so that's the 1/4 inch iteration. I'm going to right mouse click here, edit my table. And on the 1/4 inch iteration, I want my height to be 4 inches now. And enter and OK. So when I go back to my bracket assembly, it may wants me to update again. Now my bracket is, oh, that's so beautiful. So beautiful. I'm going to take a break here in about 2 minutes. I'm going to save this, and I'm going to go create my eye assembly. Creating an eye assembly is the same as creating an eye part. You're using variations of different components, or including or not including those components. So under your Manage tab, you don't have an option anymore to create an eye part. You only have it because we are in an assembly. We're going to create an eye assembly. And it's the same basic setup that we have here to create iAssemblies. In the left panel here, though, we have components. So we have the bracket and we have the gusset. Underneath those components, we have options for iParts. So we can include it or exclude. We can change the grounding status. So if this was going to be a sub assembly, this might be a concern. Adaptive status, we're not going to worry about that. This is the one we want to worry about. Table, replace. So we're going to generate a table down here, and we just want to be able to replace this component with whatever options we have created in the iPart for that bracket. So I'm going to move that table replace for the bracket, and I'm going to move the table replace here for the gusset as well. And you can see they both showed up here. And bracket number 1, and this is 01, also has I bracket 1 and gusset 1. So I'm going to right mouse click here. I'm going to create another iteration of this component, and it's already renamed it to -2 or -02, but I don't want bracket 1. I want bracket 2, and I don't want gusset 1. I want gusset 2. And if I pick OK, you're going to see that it's going to generate a table over here in my model browser that will be the definer of what this assembly is. Come on. OK, so there's my table. Now I have 2 iterations. This is the first one. That's the 1/4-inch plate that we slapped together. And this one here is, oh, this is the 1/2-inch plate with a 3/8 gusset. The radius looks right. The height looks good. I think I'm going to go back and I'm going to change the width on this specific iPart to bring that back. How much is sticking out of there? Let's go in and have a little quick look to see how much too long this is. It's 1/2 inch too long. So let's go back and, oh, not the model browser. Let's go back and alter that gusset, the second iteration, in the table, edit, and the width of that gusset is 4. If I make it 3, that'll be in 1/2 inch. So let's do that. Let's just make this 3 and enter and OK. I'm going to go back up to my assembly. And as soon as I click on update, my bracket should fix itself. And there we go. OK, so I'm going to save this assembly. Yes, sir. Now I have 1 assembly, 1 gusset, 1 bracket. But ultimately in the end, I have 2 brackets with 2 different thicknesses of material. I have another bracket with a different thickness of material. And I also have suppressed a feature. So I modified my axle mount. I eliminated the hole and I decreased the size of my gusset. Well, my gusset now matches to suit.
So should we give a material to the gusset too?
Good point. Good point. Let's go back to the gusset. Let's assign our material right now. I've selected the component. Basically, well, I only selected one face. Selecting the entire component, you can come up here and pick material. And this window has never come up right. Let's go down here and let's make this, let's make the same material. That just makes it easier for the welder. A couple things about this material editor. You can come in and you can, despite the fact that it is carbon steel, under the appearance tab. So there's 3 tabs across the top here. This one will define the mechanical strength. And we're going to get a little bit further into this once we get into plastic injection molding. But what I'm looking for here right now is the appearance. And you used to be able to just click on this button here to be able to change the appearance of it. And that's just controlling the thumbnail, but down here we have tint. So if we wanted that color to actually be something different, we can come in, click on that RGB box, that long RGB box, and redefine the color. Oh, this is green steel. Everybody loves green steel, especially the Hulk. Okay, and cancel. And now when I select that material here, whoops, sorry. You can see the material has been edited, and we can't assign it to selection because we haven't selected anything. Boom. Select this and then assign the material. Right mouse click, assign to selection, and we are golden. So now we have a material assigned. If I wanted to actually control my Ipart to have material substitution, you can do that as well by going into the table. We're not going to do it today, but I'll show you how you do it. If we edit the table, I can add a column here that will control the material. So under properties, I believe, and physical, there's our material. I can push that material or use the arrows to send the material over here. And now we have option to change our material. There's no drop down here. If you want to change the name of this, you have to know exactly what it is. If I come in here and I put aluminum, that box turns yellow because it can't find that specific material, because there is no material in the material list called just aluminum. Well, if you're specifying aluminum, I know the one I know is aluminum space 6061. I'm not sure if that's case sensitive. No, it's not. But now it will have that option because that is a material. Then this second iteration of this component is going to have all of the physical attributes assigned to it of aluminum 6061. And you can see that it changes up here. And if I go back to my other gusset, which is steel, boom, this one's going to come back and it's going to tell me that it's steel slab, carbon. And it's green. Now, I wouldn't suggest that you try and weld an aluminum gusset to a steel bracket. So I'm just going to go back to my table and I'm going to change that back. Edit table and just change this back to steel carbon. Steel, comma, space.
We can change the color for both the iterations, right?
Pardon me?
We can change the colors for both the iteration, right? Like if one
Yes,
is
you
green.
can.
Yeah.
They can both be steel carbon, and you can change the color of two steel carbon parts to be different. But in my case, they're green because this is the Hulk bracket. Actually, it didn't transfer along to the assembly here, so maybe we'll update. There we go. And I did not color the actual bracket yet, but the gussets are both steel carbon. Okay. Oh, excuse me. All right, that sneeze is a sign for me to take a break. It is 10 o'clock. At 10, let's take 14 minutes here, boys. At 10:20, I'm going to come back and we're going to create a drawing package, 3 sheets, which will be very close to what I am expecting for your submission for this first assignment. So I'm going to pause my recording. All right, gentlemen, we're back and carrying on with the Ipart and Iassembly demonstration here. We've gotten to the point now where we've created 2 components, created Iparts of each of those components to have 2 configurations basically, and they show up under the table in our model browser over here for the specific components. And under the assembly, we've also created an Iassembly where we can substitute different components in and have representations for those assemblies thusly. We've manipulated the parameters of the component to include or not include specific features. And we have changed our sheet metal rule in the case of the bracket here. We've changed our sheet metal rule to amend the thickness of the component as well. And we can manipulate a lot of the different features and the attributes of these components, including the material and the colors and all that kind of stuff, using the Ipart tools that are available to us. And now I want to finish off my assignment. So if this was my assignment, I now need to create some drawings of these components. I'm going to leave it situated on number 1 because this is going to rename my my drawing to the first component that I bring in. Because Inventor used to be kind of tricky to create IDWs. IDW is my preferred format, and I will normally ask you for IDWs because they are smaller and they are more adept to converting within the Autodesk line of products. DWGs are bigger, bulkier, and do not have as much transferable specific intelligent information from Inventor to DWGs. So I'm going to right mouse click on my IAM at the top level here and create a drawing view. This used to always bring up just the standard IDW, but if your panel is set up correctly, you have access to a standard IDW. I'm going to create that IDW now by clicking the create button. And what size is this drawing? Oh, look, it looks like it comes up. The selected file is out of date and has no generated members for view creation. A factory must be updated before views of its members can be created. You will always run into this if you don't do this first. So I've deleted that drawing. I want to do this correctly the first time. I'm going to come up to my bracket here. Let's go to our file manager first. And you can see that under my iParts and iAssemblies, I have an iBracket, an iGusset, but I don't have an iAssembly directory. That's because I haven't created those components yet. So it needs to have those components created before you can use them as views in a drawing. So I'm going to go down here and generate files. So I'm going to right mouse click on each of the components and yes, save everything and okay. And okay, let's just keep saving. And then I'm going to right mouse click on this one and generate this one as well. And now when I go to my file manager, I have an iBracket assembly, and within it, I have the 2 configurations. Okay, so we are now set to create the drawing. So right mouse click, create drawing view, select the standard IDW, and let's not concern ourselves with size when we're doing this. I'm just going to cancel the view insertion for this portion right now. And I want to just quickly go through the manipulation of our sheet size and the size of our text box. The drawing resources tab, or the folder that's up here, it will open up, and these are some options that are available to you. Sheet 1, that is here, its options are already selected and put down below. So we have some options as far as the default border. If I don't like that default border, I can just hit the delete key and get rid of it. And I can also do the same with that text box. And now I just have a blank page. So if you want to create specific size sheets, use specific templates that would bring up a certain title block for you, then you can find those. So the default border is acceptable for all sizes. And it will adjust its size depending upon the sheet size you select. The title blocks, you have two options that are available here to you. You can create more and add them to this list as well. But we are just going to go with the ANSI large. So I've just basically deleted everything and restructured it. But I'm still in a D-sized sheet. If I wanted to manipulate the size of the sheet that I wanted to work with on the sheet that I created, I need to right mouse click and edit the sheet. You can also get there by coming down to drawing 2. Oh, no, you can't. You can't do that anymore. Okay, so you have to do it in your model browser and come down and edit the sheet. The edit sheet panel comes up here, and I want to name this Iassemblies because this is what it is, Iassemblies. So we're going to have 3 sheets. First one will be Iassemblies, and then we'll have the I bracket and then the I gusset. So here is where you can manipulate the size of your sheet. You can come in here and I could change this to a C size and print or press OK. And it's manipulated the size of the sheet, the border, left the text box the same size. It's all good. I'm not certain how much space I'm going to need. These brackets are not that big. Let's try with the C size. I'm going to put 2 views of each bracket on each, maybe 3. Who knows? So let's go in and start adding our base views. And it's going to ask me to select the document. I'm going to come in and I'm going to go with Ipart Assembly. Oh, not that one. This is the wrong class. Let's go into section 3, Iparts and Iassemblies. And I'm going to pick the I bracket and open. Whoops, I lost my share again. And, oh, I know why. It's because that open button is right by the stop share. Open, okay. So there is my bracket. Is that the view that I want? Let's just have a look at it. We can rotate it. And if I show that view and the top one, I'm still going to need a right view. And I might, just for the sake of getting them both on the same sheet, let's reduce the size. I want that view, right view. I'm going to make it 1.5, 1.5. So I'm just altering my scale so that I can get a little bit bigger representation. And I also want to be able to see this component. That's the back, that's the other side. Okay, if I have the front view and the right view and the bottom view, that should work, but let's rotate this way, and I'll have that view there, this one here, and okay, I like this. I'm going to put this one down here. I'm going to move this view over here. I'm going to put one more view up here. And I like that. Okay, so this was our Iassembly -01. I'm going to pick OK, and I can look and I can see that this file has been named after 01. I'm going to do a file save as. I don't want it to be named as 01. I just want it to be Ipart Assembly. And it's an IDW file, so it's not going to overwrite my assembly file because it's a different format. So I can just save that now. My title will change down here. And I have a view or 3 views in here showing me the first iteration. I'm going to put my second iteration over here. So I'm going to add another base view, and I'm going to select my document, which will be the I bracket assembly. Open that up. I'm going to change my scale again to 1.5. And I'm going to put the same views on, but this time I don't want the same 0, 1. If I come to the model tab in my drawing view insertion panel, I can see that the member that I'm actually displaying here is -0, 1. We've already got those 3 views here. Drop down menu, go to number 2, and here is number 2. So I'm just going to rotate this once this way. I'll rotate that way. And this is the same view as this one over here. So I can use this view. And this bracket is a little bit bigger. I can use this view to create the 3 views I want for this assembly. Pick OK. And let's start with some dimensions, I guess. First thing I like to do before I do any dimensioning is put my center marks on. There's not very many required in this case. The 2 should do. That hole is basically just there so that we have a feature that we can suppress. I just want to be able to see that you guys can do that between one Ipart and another. Let's add a couple more dimensions here just for reference, because these components will be created before they go to the fitter, and he doesn't necessarily need all the information that's here or all the information for each individual component, because they will be on separate drawings on the next 2 pages. Okay, and I just want to make sure that I am consistent and I mark or add the same dimensions to each component at the same, I guess this one could go here. Boom. And let's also define the position of this guy here. I'm going to do that with the center line. I guess we could do it right here in this view by just grabbing the end of this center line after we select the center line command, bring it down to the center of this component or this line down here, right mouse click and create. Now we have a center line that's an obvious center to that component. We could put another center line here by selecting that point and this point, right mouse click and create, and then we can add a dimension. And let's do the same for this fellow over here. Boom. The thing about dimensioning, well, there's lots of things about dimensioning, but try and be logical. And when you're doing situations like this, where we have multiple components on a single page, I like to try and go through and make sure that everything is added in a very logical and consistent format. So you can always be sure that you've got the information you need. That looks good. Oh, let's also include this dimension here, which will be our radius. Well, actually, I want this to be specified as a diameter. So while it is still elastic on my mouse, I can right mouse click, go to dimension type and change it to diameter. And if I wiggle around enough, it'll come back to that. And let's go over here and do the same for this cutout here. And again, it's specifying a radius, right mouse click, dimension type, and diameter. So these are all reference dimensions, except for this one here. the ones that's locating the gusset. Oh, I should probably also include the material thickness here. If I pick the bottom of this line first, if I just pick this line, I can put my dimension in, but I'm not sure where this 0.25 is going to show up, in the top or on the bottom. And I can't really change it at this point. If I go and create my dimension, but I select the bottom first and then the top, that dimension will show up on the bottom. Come over here and do the same with this one. Select the bottom first and then the top, and the dimension shows up on the bottom. Okay, that looks good so far. What are these components? I know these components are iParts that we created from another, from two separate pieces. So we have 4 parts on here. What do we do for a bill of materials? Well, let's just go into a parts list. And let's select this view. This view is going to tell me what parts are in it. So the view will dictate what goes in the bill of materials. And of course, the BOM disabled view saying, do you want to enable the view? Yes, okay. And now we have a bill of materials. I don't have a description. Okay. So this is the I bracket and the I gusset -01. Let's go to the I bracket, and we're going to insert our description into our I properties. Now I moved back to the I bracket because I need to save this before I can go back up and make sure that those changes do take place in that bill of materials. So right mouse clicking on the tab, opening up the I properties. It's that simple. I properties, and come to the project tab, and under description, I'm going to put in here what it is. It's just a bent bracket. And do I need a rev number? Not in this case. The revision is going to be a component or an I property of the sheets that we create or the bracket assemblies. So I'm just going to pick OK and save. I'm going to come to my gusset now, move to it, I properties, go to the project tab. Under description, I'm going to put gusset, GUSSET, and OK. It doesn't matter which one is being displayed, whether it's -01 or -02. Just pick OK and save it. But I come back up to my, I don't think I have to update this assembly. No, I just got to go right to the drawing. And my description should show up. Let's just save this, and then, oh, come on. Why you got to be like that? Let's just get rid of this, and then we'll put it in again. Let's pick this guy. Oh, maybe it's because I was on the other one first. We still don't have our description. And I don't know why that is. Let's go back to the bracket here. We are in bracket number 1. And there is no I properties for that specific bracket. And this gusset is on number 2. And if I look at the I properties, the I property description should be correct in the project tab, gusset I. I won't need that title. Let's close this. And back up here. And there is no refresh. Defer all updates. No, I don't want to do that. That's the I properties for the drawing, and I'm not going to concern myself with that right now. I properties, project, gusset. Yes, it's there. and iProperties and project. And yes, it's okay. Okay, let me try this one here. You know what? Let's delete this and we'll select another view, a different view. Parts list. Let's select this view and assembly. Yes, it's selecting it from the correct source. Okay, and let's try the other one. Okay, this one has it. The difference. What is the difference? It's item 3 and 4, and this is item 1 and 2. This is making perfect sense. Let's just go into the gusset here. And okay, let's just open that. Let's, I'm just going to regenerate these files. I think it was the first iteration actually that we had the problem with. This one. And generate files. And come back up to the top level here. And it's still not updating. Let's go to our let's open up the actual files. This happened to me the other day as well, and I don't know why. But if I open up one here, and let's just check the iProperties on this guy here, I cannot check them. Oh, this is interesting. Well, I don't like it when that happens. Delete that. Try it again one more time from here. Okay. Yes, son of a gunama. Okay. How to fix this? Well, let's open up the. Okay, so it has the names here, but it doesn't have them there. Let's go and edit. I really don't like that title. I don't want that. And it's not going to change anything. Column chooser is let's remove the description here. Okay, and let's re-add it under the column chooser and find our description, add, and okay. And it's still coming up blank. Any suggestions, gentlemen? I am as stumped as you are. Aha. This one, what's this going to do? It's still not giving us what we want, member selection. It's not in the filter settings. Okay, so I did open up 01, and it's not going to allow me to to affect the I properties of this, because the I properties should trickle down from the master component, which is this one here. This is on 1 and the bracket is on 1. And it's the ones that we're missing in our IDW. Up. So the reason that description is not showing up in our bill of materials is beyond me. Okay, let's go in and we're going to select our document this time. This time I'm going to go into the I bracket assembly and I'm going to select the first configuration and then okay. And hopefully, no, still not there. Huh.
Maybe it's the views or something. You have to select. For the other one, we selected the view, like the
Yes,
third
that's
view.
true.
Yeah,
Well, we'll try that again. We'll select the same view or a view that is a part of that. And it's selecting it from the I bracket assembly, but it's not selecting, it doesn't allow us to, it should figure out that it is the first iteration of that assembly. And those are the only options that are available to us. Save that. Save this. Yeah, I'm going to have to do a little bit of homework and figure out why that's not happening. If you guys have issues with that, then I will have an answer for you next week. Let's carry on. I'm going to create, let's finish our I properties for this sheet. Doing multi-page sheets is going to create a certain efficiency for you guys where you don't have to go in and add your I properties to every sheet. So one single drawing file, one single .idw file will be controlled. Its I properties will be manipulated here. So I'm just going to call this I bracket assembly. That will be my title, and just to make it prettier, I'm going to move it up the middle there. I'm going to call this company as Tilo 20. I still have that company. I'm just a little busy with school these days. Please be sure to include your rev level. I will be checking that constantly. That is a function of your PDM, your product data management, and it will be required no matter where you go. And I don't need a description or a stock number. The part number, it looks a little long, but we're going to just tweak the size of that when we get to the right spot. Okay, so we have everything in the title block as we need. I can close this. There's a couple things about this title block that I don't like. I don't like the fact that my part number is running into my revision level. I don't like the size of my name. I think my big company should have a big name and it should say something meaningful. Well, at least large anyways. So let's go in and edit this text box. Now this text box is a lot like a block in AutoCAD. Thankfully that's behind us. So I can go in and I can edit this text box to suit. So as a block, it's listed right here and it's called ANSI large. And if I edit the definition of this block, it'll open it up as the sketch that it is. It is just a sketch block that is saved and called ANSI large. And I want this company name, I want that to be huge. I want it to stand out. So I can either pick a value from the drop-down menu, or I can type in the value that I want. 0.35, sure, that sounds good. And let's make it bold. Why not? That's going to stand out. Okay, so that's changed that. What was it? It was the part number was too big. It's already set at 0.12, no, 0.18. Let's change that to 0.1, and that should fit in there nicely. Was the title okay? We can make the title a little bit bigger. It has to be highlighted. And oh, maybe 240, that might be too big, but we'll check it out. So once we've amended our title block text boxes there, we can finish the sketch, save the edits, and that looks much better. I think I'm going to change the text size of this drawing number just a little bit bigger. Oops, title block. Oops, it's down here. Yeah, when you once you get back here into your drawing, you got to reopen the page that you're editing the title block for. So let's come here, edit the definition again, and double click on part number. Boom. Come here. Or zoom in, it's cheap. Zoom in on part number, 0.12. Oh, it's 0.1. Let's make this 0.15. So you don't have to select the necessarily select the drop-down values. You can make up your own values as well. And I'm going to save it. All right, see, it's still within the box and it looks good. Okay, I'm going to save this sheet. I'm going to go up to the top level here. Whoops, yes to all, and okay. I'm going to the top level of this drawing. I'm going to right mouse click and put in a new sheet. It's going to enter another sheet that is formatted exactly the same as the previous sheet, except it has no views on it. And for this sheet, I'm going to put my brackets. So I'm going to, first of all, let's go in and edit the sheet. And let's just change the title of this to, oops, Shift I and brackets. I bracket. And I think we'll leave it as a C. Maybe we should make this one a D because we do have flat patterns to put on. Let's go with a D size and okay. I know we're only doing 2 views, 2 or 3 views, and then a flat pattern. So let's drop our views onto this this drawing. Place views, base, and we have to select the document. And in this case, we're going to select the actual I bracket and open that up. And is this the view that I want? I want at least a side view, something like that. I think I'm going to rotate this way, and then my top view will be there. And then I put flat pattern up top. And I think I can go with a little bit bigger because I did make this a D size now. So now it's 1:1. If we look under the model, we can see that, yes, we're still on the -01. This looks good. Let's put a view here and one view over here. And I can pick OK. I'm going to add another base view of the same component. So go back to the I bracket, open that up. And there's nothing saying that you can't put these all on a, like all these views for everything onto a single page, but it would just, it's a little bit more divided up, a little bit more logical in my mind. So I'm going to move the flat pattern up there. I selected it from my, my menu over here and pick OK. And I think I'm going to move this view over here. We don't need that much space, and then this one can go over. And let's insert our base views for our next component or our next I bracket configuration. So I bracket and open. and go back to the model, and let's select the second member of this configuration. Let's rotate him sideways. Oops. That's not really what I want. I wanted to rotate that, and I actually selected the view. So let's cancel that. Let's add the base view again. Let's select the document that we want, which is the I bracket, and it's the smart file. It's not the ones that were generated. Let's move this way. I want it to be, again, I want it to be the same basic configuration that we have over there. So I'm going to rotate this once this way. Oh, doodly. So let's turn him around that way. So this view is the same as this one. I'm going to move it to here. I'm going to put this over here. I'll move one up here. And wait a minute. There we go. That's better. I was wondering why that hole was still in there. Okay, so now we've got our larger bracket. And let's pick OK. Let's go back, add one more base view. We have to go in again and select our bracket, our I bracket. And go back to the model and change it to the second configuration. Go back to the component here and change it to flat pattern. And I'm going to leave that there. And I'm just going to come in here and move this view down. I want a little bit more room for my flat pattern and its dimensions that are required. So you'll notice that the views are kind of identical, despite the fact that they are different components. Let's go in and dimension the heck out of this guy. So what do we do first? First, we update everything. Why is that update not going away? There's no updates there. There's no updates there. There's no updates there. I'm going to close this gusset. Don't need him. Close. There we go. All right. I don't know why that's still on, but let's carry on. And I'm going to dimension, annotate, go straight for my center marks, and I just slap them on all over the place. And I need one here, and I need one here, and I need one here. Let's put a few center lights in, at least to identify the location of this hole, and create. And again for here, same. Create. I don't know that I need this center mark all the way through here. Basically, this line is going to be perpendicular. Let's start some dimensioning. I always like to take care of my overalls first. So there's an overall dimension on my flat pattern. Let's do it over here while we're at it. And let's do an overall length on our flat pattern. Let's make sure that we leave enough room for a dimension to our bend line. Oh, I forgot my center mark over there. Why didn't you guys tell me? Here, put that one there, and this dimension here. Now I'm going to put my bend line dimension on the top. I'm going to put the dimension to that hole on the bottom. I know I'm dimensioning from both ends, and it's not really considered good form, but you know, sometimes this is the way things go. And I also need dimension on this fella here. And in this case, we can dimension this as a radius. I wish he would. There we go. That's what I'm talking about. If you elastic band that radius dimension around enough, you will get the arrow into the option that you're looking for. I need a dimension on this hole. And I've got to put my center mark on here as well. I forgot. Now let's put some dimensions in here. This and on this radius. It can be a radius in this case. I only put it down as a dimension on the assembly. That's going to be the application dimension. So when somebody says, "Oh, I need one of those brackets for a 2-inch diameter," well, that's the one he's going to pick. He's going to pick the one with the R1, but he doesn't need to identify it as a 1-inch radius. He needs to identify it as a 2-inch diameter. Okay, now these are the form views of this component. Oh, finishing off these bent views. If we look under feature notes here, there is a bend icon. And if you just click on it and then click on the bend line, you're going to get yourself a lovely little note telling you the angle and the radius. And I'm going to click on this one as well. And it's going to pick the information from the sheet metal file that we created. Let's go ahead and put some dimensions on here, because the operator will need to check his part after he bends it just to verify his sizes, because if the part was cut too long in the first place, if this 9.92 was 10.5 and he lays it out here, he's going to get this height, but he's not going to get this length. So he'll realize that he's got a problem that needs to be resolved. Let's put a radius. This is our bend radius. And let's just put a width on here. Let's go over here and do the same. Oh, I need a thickness here as well. Material thickness is probably a good idea. And let's put this dimension on here. Let's put a radius. Don't be afraid to zoom. The only reason I'm not zooming in is because I want to reference this other view here to give me consistency in my dimensioning. I got one dimension there. I need the thickness on here. And I need across the bottom. It's never a really good idea to dimension the outside radius. That's not something they're going to try to hold. That radius that's on the outside, in this case, it's going to be an R.75, but it's not, it doesn't really mean anything. What this R.5 means is that's the size of the tool you're going to use to bend this. Do we have enough dimensions now? Okay, I think that basically covers it for our bracket. I want to make sure that the operator or whoever's looking at this print is going to be able to delineate that one part is different from another. So I want to create a sketch, which is going to be a single line straight down the middle to divide this sheet into two pieces. So I'm going to start a sketch. I'm going to click on this face. And let's just draw one straight line. And about here, yeah, it would probably come right off that arrow, would be all right. And straight down. And end. Okay. Finish my sketch. Beautiful. Beautiful. If I never see this drawing again, that's the blessing of doing something right the first time. Draw it once and I guess I could put this little dimension in here too. Let's go back to annotate. And I want to include this center line here. So I'm going to come from that line to that line. And I could have put that in a couple of ways. If I Control Z that, I could use the standard center line and just pick the center points here, if those are available to you. But if this diameter was not in the center, you could use the center line bisector, which would take two lines and put a center line right up the middle. Okay. All right, now, the only thing missing from this is a little bit of a note that says flat pattern. So the operator will definitely know what the flat pattern is. So let's go in here and just go flat pattern. And let's make this bold and underlined, and let's bump that text up to 240. Okay. And I'm going to drop the same note right here. Dang it. Let's go back and edit this one. I am pretty lazy, guys. I really don't like typing. I'm never any good at typing. I love dictation software. And if I can copy and paste anything, I will. There we go. Okay, and now I want, at the bottom, I want to put the actual numbers, the part numbers that they are. So let's go in and I'm going to paste that just so that I have the same formatting. And then I can just overwrite it with what I want. So this is I bracket. I bracket. It's a pirate bracket. I bracket and 8647356-01. So that is the complete file name of this component. And I'm going to copy this much of it. Control C and OK. Then drop another note over here. And Control V and make this 02 and OK. All right, so this part is done. Properly labeled. I have enough dimensions. Can you see any dimensions I'm missing? I have the material thickness. I am not specifying the material on this. I'm not going to have you worry about that in this case. I suppose I could go in and grab this center line and just drag it all the way over here. That wouldn't be necessarily a bad thing, but it'd probably look better if it was a real center line. So we'll put our own little center line in there, all the way to there. And boom, right mouse click and create. Okay, I think that looks pretty good. We've got a lot of airspace on there. We probably could have got away with doing this on a C size, but I wanted to make sure we had enough room. I'm happy with that. So I'm going to save. Okay. Why that update's still on there? Okay, let's go up to the top level again, right mouse click, and let's put in new sheet. So now we have a duplicate of the second sheet. So this again is a D size. This sheet here, I don't think we're going to need a D size because it's just going to be those two gussets. So let's edit the sheet. Let's make this sheet a B size. And let's call this I gusset. Good thing we aren't designing robots because we'd have to do an Isaac Asimov copyright infringement. Does anybody get that? Okay, so I'm going to add my gussets here to this view and place views, base, and this time I'm going to select the I gusset as my insert part. And under the model, I want to make sure that I'm on 01 and I can go OK. Oh, and I've selected this view. So I'm going to double click on it. And I want to edit this view. I want that view. And this is 01. So this is going to be a little bit, now maybe we'll put the big one over on that side. So we'll put 1 on this side and we'll put 2 on this side because we're going to have more room. And a side view, just good practice. I'm going to go OK. I'm going to insert another gusset. This time I'm going to go to my model and I'm going to select number 2. And I'm going to rotate it this time before I do anything. So just select this. Oh, wrong way. Let's keep going. Just keep moving. And we'll put this gusset over here. Yeah, we'll have lots of them. B size. Okay. And dimensioning. Easy peasy lemon squeezy, right? Whoops. That's not the dimension icon. The dimension icon is in the exact same spot when you go to the annotate. We don't need any sending marks on this, so I'm just going to jump right to the dimensioning. And there's 0.5. And there's the height. And here is the width. Okay, I don't know if I like that. It looks like I could have moved that dimension. I just don't have a gap there. I'm a big fan of having gaps. Okay, let's put this here. And let's do this. Oh, don't. Okay, let's do the same thing with this gusset. Height. I would always prefer to have the height come on the side like this, as opposed to bringing that dimension all the way over to the left. Not a good idea, because you may be confusing an operator by having an excess of dimension lines that would make his component look like it was square. Okay, and if I put this dimension on here, then I don't have to worry about having a typical note on there as well. So that's just as easily done. Okay, it looks pretty good. Any more information I need on there, gentlemen?
Just add the notes like cassette 1, cassette 2.
Okay, so those notes, if I come down here and add a note, if I just hit Control V, what do we got? Okay, I can just go gusset. Change this to I gusset and -01. And I'm going to copy this. Even after I finish with these notes, there's still one thing missing. Anybody know what it is? Oh, you know what?
Middle line.
One. I can, even after I finish that, I put the wrong note on here. This is 2 over here on this side. Boom, 2. And okay, because I needed a little bit more room because of the thickness of the part. Let's go into our sketch mode and start a sketch on this face and get this line and run him right down the center. Oh, let's run that line so it's straight up from this corner. This is not going to snap to anything here. So it's just your best guess to get it as close as you can. Whoopsie, too far. Back in here. And I want that to be perpendicular. You can see the vertical line in there, the constraint, the geometric constraint was in there. Okay, that and finish the sketch. Okay, still missing one thing. There's no bonus points, but I will give you a pat on the back.
Fillets are not dimensioned yet.
Sorry?
The fillets are not dimensioned yet.
Oh, you're a smart guy, girl. Okay, good. Let's go back to annotate and dimension. And in this case, I will put this dimension right on the part. It's going to stand out. It's going to, and it makes sense to an operator when he sees that that is an inside radius. And if I wiggle this around enough, I will get it right. There we go. I don't know how that works, but I just know that if you keep doing loops, it will eventually turn to the correct dimension. To have an R.5 with an arrow coming from the outside, yeah, okay. I'm not a big fan, but this is what we got going on. Okay, so I'm going to save this, and okay. And I'm going to go back to the highest level of this, which would be the assemblies. Well, any print in here will be the highest level of this component. I'm expecting you guys to be able to complete this by the end of class next week. but we'll have a look next week to see where you're at. And if we extend it, so be it, because I don't have another assessment for another 2 weeks. So you're going to have a little bit of time to complete this, but I don't want you to put it off. I want you to stay practiced and focused with Inventor, because we got a little bit more higher level of complexity in some of the issues that we're going to face down the road here.
So what about the description in the the bomb? So we skip it, or
You know what? I don't know why it didn't work out for me today, but I expect you guys to make that happen. But I don't expect you to have it done by the start of next class. So next class, I will have this solution for you, and I'll tell you why this messed up on me. And if you're having the same issue, maybe you won't even have this issue.
okay.
Okay. I want to run through my pack and go now. So I'm just want to save everything. I want to go, okay, I've saved it there. And if I go file and save all, save all, I know that everything is saved. I can go through, I can double check my prints, make sure everybody's okay. All my dimensions are there, my bend notes, my labels, my make sure everything is correct before I run my pack and go. I got my radiuses, I got my dimensions. And you know what, when you're having eye parts like this on the same page, it makes it real easy to go back and forth to verify that you have all the information. Make sure you verify. And if you have a D size and a C size and a B size, 3 different sizes of print, I don't care. I want you to draw this so that the parts are suitable for the size of the page. So that is a judgment call that you guys are going to have to learn to make. You have to have enough air in your drawing so it's not crowded. You don't want things too crowded together, but you don't want a lot of dead space on there either. So somewhere in between too busy and too airy is where you need to be. Well, I guess I could put a vertical line on this one too. I may as well do that while I'm here right before I submit. And I'm going to draw a sketch on this drawing here. And I'm going to come from this arrowhead up to this arrowhead. And okay. And finish my sketch. And save. Okay. All right. And I did make sure I had those dividing lines on my other 2. Beautiful. Okay. So this is the highest level of this drawing set, page 1 of 3. And the beauty of using multiple sheets within one .idw file is that your title block will be updated. And despite the fact that this is the name that is in the title block, the I bracket description, when I go to sheet 2, yeah, it's I bracket assembly, but here we have I bracket, and here we have I gusset. So there's enough information there to help even really dumb people. I'm kidding. There has to be enough information there to make it blatantly apparent what your intention is as far as description. Okay, yeah, I guess I placed those gussets. I'm gonna grab this view. Let's move him down a little bit away from that bill and save. Okay, and update. I think that's what this update is. It's this description. Something's stopping that, and I will interrogate that and find out for you by next Wednesday, for sure. So I'm all saved up. I'm going to do my pack and go now. So file, save as, nope, file, save as, hovering, and then down onto pack and go. Can you see my pack and go screen?
Yes, sir.
Okay. The very top line this is telling me where all the files for this pack and go are coming from. The assembly model of at the highest level will dictate, will tell me all the components that are included in it, because it's like the bill of materials. This source file is the one that knows all the parts that are contained within my submission. The destination folder. Okay, so I've got this set to section 4. This is from last class. So I'm going to go change that. I'm going to find my section 3. And Ipart assemblies. Yeah. Oh, you know what? You can't put it in the same directory as the source file. So that source file is in this directory. So if I wanted to put that somewhere close, I could put it in my section 3 directory, or I can come to, where's my file manager? My file manager, and we are section 3 iParts and assemblies. Let's just go here and create a new folder, and I'm going to call this assignment. Now, this assignment folder is for your reference only. Your assignment will be named like this. So back into my pack and go, I'm going to come in and I'm going to browse for that assignment folder, because I just want that to be separate. So here's section 3. There's that assignment folder I just created. I'm going to go in there and I'm going to click OK. So this is just the folder where it's going to be. The name of this file, I'm going to put in a backslash. And this is going to be called assignment 1. Space dash and student number 8647356, but your student number. So this is assignment 1. This is the name of the zip file that's going to be created when I execute this pack and go. I don't have to put anything after it. Do not put another slash. Do not put a dot zip, just assignment 1 and your student number. In your options over here, I want you to copy to a single path. We can include link files as it is. We will skip libraries. If we don't skip libraries, and I take the check mark out of there, okay, don't worry about libraries. Just leave it as skip libraries. We're not going to collect work groups. That is part of your Vault, your Inventor Vault situation. But we're going to skip styles. If I don't skip styles, then it's adding 31 megabytes to my file size. So skip styles, skip templates. That's another 10 megabytes I don't need to add. And I want to package as zip. The file size is still 0 now because we haven't done the search. And you can see the project file reference is right here. It's a W22. That's everything in that directory containing W22, including the directories that I've created. So I can do a search now and look at all the files. Okay, so there's my IDW. That's the drawing. That's the 3-page drawing right off the top. I have 1, 2 brackets. And down below, I see that I have my I bracket. So I have the I bracket and my student number, and then I have I bracket student number -1 and -2. These are the files that were generated. I need those submitted as well. I have 1 assembly, I bracket assembly with my student number. Then I have 2 more assemblies underneath it, -1 and -2. Then I have down at the very bottom, I have my I gusset with my student number. And then up here, I have I gusset my student number -1 and -2. Those are all the files I want submitted. So altogether, there's 3, 6, 9, 10 files. So 1 gusset, 1 master gusset, and 2 other files, the 1 and the 2. That's 3. 1 bracket, that's the master, and 2 configuration files, 1 and 2. So that's another 3. That's 6 altogether. 1 assembly, and then 2 Iassembly files, assembly 1 and assembly 2. That's 9 altogether. And then the drawing file is 1 file with 3 pages. So that's 10 files altogether, 2.8 megabytes. If you're looking at your file size before you start your zip, and you see that your file size is 22 megabytes, well, okay, I better check my options here. Because if I include something that I don't need, now it's up to 65 megabytes and as high as 84. If I download those, there's marks to lose if you do not do your pack and go correctly. So if I'm downloading a 30 meg file, you can be sure you're not going to get your marks for that pack and go. You get marks for whatever's inside of it, but I will not give you specific marks for your pack and go style attempt. Okay, so once I have the 10 files, I have my options the way I want them. Make sure you do click that package as zip. I'm going to click my start button, and it's telling me that assignment 1.8647356 does not exist. Create it. Oh, yes, please. Thank you, Mr. Inventor. And once that green line gets to the end, you may select done. Here is my file manager, and I have an assignment directory up here. And within that assignment directory is the zip file that was created by Pack and Go. Assignment 1.8647356.zip. I'm ready to submit. No, I'm not. One more thing I want you to do. I want you to double click on that assignment, that zip file, and have a look inside. Make sure you have all the files you need. It's easy to do by sorting by type. And it's going to bring this out a little bit. So I have 3 assemblies. So I have a master and I have 2 configurations. I have an iBracket master and 2 configurations. I have an iGusset master and 2 configurations. I also have a pack and go log. I have an iBracket assembly project file old, and I have an iBracket assembly.ipj. So this is another project file that was created by Inventor, and it will always show up when you create your pack and go. And then I have my OneDrive. You'll have a folder in there called old versions. Don't worry about that. It's just a backup, and it's fine. So I have my submission, and I've got the rest of the week to do whatever I want. Any questions, gentlemen? Danik.
Sir, for the assignment purpose, should we have to do a same part that you did?
Okay. Now this is something I've been doing this for about 4 years now, and the duplication process is fine for the first and second level guys. I would love to see some of your own ideas. If there's something that you want to try to create using different configurations of components and assemblies, then by all means, I want you to try that. If you're having issues with it, give me a shout, send me an email. We'll make some time to do a Zoom meeting and share some screens. Maybe I can help you out. But consider this course an opportunity for you to develop some fodder, some material for your own portfolio, something you can use for a resume. And you can say, this is my idea. This is my idea alone. I came up with this, and these are the concepts that I'm trying to explain here. So if you have some original work that you want to include in this, by all means, please. It makes it a little bit more interesting for me when I'm grading as well. And I love to see the level of enthusiasm that is possible when you are doing your own thing as opposed to duplicating what I'm doing. But if you want to duplicate what I'm doing, I cannot stop you from doing that. I am asking you to follow the guidelines that I've set out within, whoopsie, within the parameters of this assessment here. I will be updating this list by the time Monday comes around. There will be a lot more detail, and it's going to include just the common sense stuff that we went through today, just so you know that when I create the rubric, these are the things that I'm going to be grading, such as parameter controlled by equation. Did I do that today? I don't think I did. I don't
did,
think I
like
Did I?
thickness by 2.
You did a thing like thickness into 2, stuff like that.
Yeah, okay. Equals is a parameter.
Now that was the other one, the thickness into 2, or I think the hole or the gusset.
Oh, the thickness times 2. That was the
For the
bend
fillet,
radius.
for the radius, thickness into
That
2.
is a, yeah, I guess we could
Yes, sir.
consider
For
that.
the
the
radius of
equation.
the flange, you did the same.
Okay, or width divided by 2. Okay, the location of that hole, that was it. So the location of that hole is the width divided by 2 and the height divided by 2. All right, so yes, be aware of that. And those formulas can get pretty complex. And you know what, I never even touched on creating an Excel sheet to control these components. But this is all so easily done if we edit our table as a spreadsheet. And if we were to make changes to our drawings at this point now, then they will update as soon as we close this sheet. So I could modify these. I could modify the values in my Excel sheet, and they would update in the drawings after I close my Excel sheet. But what I think is a little bit more important for you guys, if I tied this sheet, and if you're at all handy with Excel, you know you can tie the value of this sheet with the value in another sheet. So if I have 2 different components, I could tie, for instance, the height of the gusset to the length of the flange on this bracket. So there's potential to be able to create a control or a level of control that would go across parts, across from one part to another. I'll touch on that a little bit more when we get further into our semester. Okay, any other questions, gentlemen? I got to figure out what this description issue is. I'm making a note as we speak. Description in Iparts. Okay, that's 3.5 hours, gentlemen. Sorry to keep you so long. I know that they mandate that I only teach 1 hour and 20 minutes, but we had a lot to get through. Next week, it's going to be another long lecture as well, because I do have a few things to get through, because we are looking at, what are we looking at? CAD data exchange, and we're going to just brush through Fusion 360, Onshape, and I want to spend a little bit of time on Autodesk Recap Pro. Okay. Oh, and this says quiz, but don't worry about that. Not going to happen. Okay, gentlemen, if you have no questions, you may leave the class. If you want to hang out, I will be here for another 26 minutes, and I will take questions and just be gabbing. I'm done gabbing. I'm just going to answer questions now.
Thank you, sir.
All right, Don. Thanks for coming.
Thank you, sir.
All right, take care, Pravin.
Thank you, sir. Have a great week.
You too, Drupad.
Thank you, sir.
Cool. Have a good day.
Yes, sir. I have a question related to assignment. Like what it exactly?
Sorry?
I have a question related to assignment. What was exactly like we will have to create just on idea and we will do a drafting bill and upload to you.
Yeah. You know what? Do you have an idea what it is that you want to do?
Okay. Just and drafting and just a one file, right? Or just assembly or just like one part or something.
Your assignment will be basically what I've done today. So I created 2 separate parts. I've
One
made
assembly.
those separate parts I-parts so that they actually become 2 parts each.
Yeah.
Then I've combined them into a single assembly and made that
Yeah.
an I-assembly. And yeah, you seen how I did that?
Okay. Later to a year, just I will have to make for my own part, right?
Yep, you can use your own ideas. Please do. If you think you need to clear it by me before submission, you may submit it and ask me if it's okay. Because if it's an original idea and you want to make sure that I'm going to be open to it, I will be. But if you're having any issues with it, like the complexity here is creating the I parts and creating the I assemblies. So I want you to be sure that you can do that. And I don't care if you do it with a flat bar and a bolt. I just need those components to have different configurations, put into an assembly, and then have a different configuration, 2 different
Okay.
configurations in the assembly, okay?
Got it, sir. Got it. Thank you, sir.
All right,
Have a good day.
take care, have a good week. I am going to stop the recording now. Boom.